Welcome back. Here are some objectives for the videos that are to follow. Right. First off, we're going to review Lowry-Bronsted theory that we just finished discussing in class. And then we're going to continue our discussion further on the topic of acids and bases, where we are going to quickly take a look at Lewis acid and bases with a few examples. And then we're going to extend the knowledge of everything you've learned about acids and bases and apply to the area of acid-base equilibria or equilibrium. And then if you're going to talk about equilibrium, then you are talking about weak acids and bases. You're not talking about strong acids and strong bases. And I'll explain that in a little bit. And then to really understand weak acids and weak bases equilibrium, you have to know how to learn to write Ka and Kb expression, where A stands for acid, B stands for base. And then obviously the ultimate outcome of writing a Ka or Kb expression is to be able to determine pH and pOH for weak acids and bases. The four formulas that I've showed you, they're the same, but you have to modify them a little bit to actually get the pH and pOH. All right, so without further ado, now this is not something I have explicitly mentioned it in my videos. Maybe I did, maybe I didn't, but I did mention this in class. Okay, if I give you a bunch of ions and I ask you which one is acid, which one is base, it's very simple. It doesn't take, if you're going to take hours to solve that, then you probably don't know what really an acid base is. Okay. Typically, if I give you an ion with a negative charge, it's a base. Typically, an ion with a positive charge is an acid. And say I ask you to find a conjugate base. If you're asked to find a conjugate base, then you remove a hydrogen. Okay. Now, when you add a hydrogen, typically you add a negative charge, but there are also cases where you'll be removing a positive charge. And to find conjugate acids, you add a hydrogen because what is given is a base, and bases generally accept hydrogen, right? And whenever you add a hydrogen, you either remove a negative charge, or other cases where you add a positive charge, right? All right, now you may not have to remember this part, but at least to get comfortable, I want you to remember this. So to find conjugate base, you remove hydrogen, and to find conjugate acid, you add hydrogen. All right, let's review some examples. So if I ask you to find the conjugate base of the following ions, all right, well, let's, so what is given is an acid, right? You don't need to even assume, that's a fact. So what is given is an acid. And when you're asked to find a conjugate base, an acid always loses some hydrogen. So you write it without an hydrogen. And then every time you remove a hydrogen, you add a negative charge. But keep in mind, there's already one negative here. You add one more negative to it, so it's 2 minus. Again, this is an acid. You write it without one hydrogen before you worry about the charge. First, write it without one hydrogen short. And then every time you remove a hydrogen, you add one negative. Okay? All right. So that's a conjugate base of that. This is again an acid. So now this is a diprotic acid. You notice there's 2 hydrogens, right? So you got to do it twice. When you see 2 hydrogens to start with, you're going to do it twice. So first time you remove 1 hydrogen. And when you remove 1 hydrogen, you add 1 negative. You're going to continue with this and remove 1 more hydrogen. So you get 2 negative, right? All right, finally. Now this is what I meant by you might actually remove a positive charge sometimes, okay? Because this is an acid, it's going to lose 1 hydrogen, okay? Because you lose 1 hydrogen, you add a negative charge, but there's a positive charge already, so they cancel out. So that's what I meant by you add a negative charge or remove positive charge. Sometimes they both actually happen concurrently. All right, conjugate acids of the following. Now, I chose this purposefully so you can actually see the relationship when we finish this. You see, it's like literally just the opposite of the two. So if I'm asking you for a conjugate acid, so what is given is a base. That's just that simple. And what do base do? They accept hydrogen. So you add a hydrogen. Basically, you write with an extra hydrogen. Every time you add a hydrogen, you remove a negative charge or add a positive charge. In this case, when you add a hydrogen, you add a positive charge typically. So there's already a negative, and you get rid of it. All right, very good. Think of it either way, either removing a hydrogen or adding a positive charge and wiping out the negative. They both mean the same. Again, conjugate acid the following. So this is the base, so you add a hydrogen. Every time you add a hydrogen, there's no negative to remove, but you can add a positive charge, so it's 1 plus. If there's no negative to remove, then you must add a positive charge, okay? That's why I have both, Now, these are not typically statements. You might find it this way in a textbook. I have written them based on my experience working with these concepts. All right, again, conjugate acid of the following. This is a base. So we had a hydrogen. I kind of repeated myself there. What I wanted really was CO32 minus. Anyways, you get the idea. It's the same. And then ammonia is NH4 plus. It's the same stuff. Okay. What I really meant to do here was, let me actually write it as NH2 minus. This is what I really meant to do. So let me strike this out. So if this is a base and you add a hydrogen, right? When you add hydrogen, you typically add a positive charge. So this negative will cancel out. So it'll be NH3. Okay. So this is very simple. Okay. Typically, I'm going to circle what is the most common thing you do. So when you find a conjugate base, you remove a hydrogen. 99% of the time, okay, 99% of the time, this is what you do, add a negative charge. That's how it works. Similarly, when you find a conjugate acid, you add a hydrogen. This is typically what you do 99% of the time. Okay, there's only 1% chance you start with a negative, like in this case. Okay, this is typically you add positive charge, which makes your life easier. All right, so that's pretty much the concept of Lowry-Bronsted theory. All right, I'm going to wrap this up with this video, and in the next video I'll see you with Lewis acids and bases. All right, stay tuned.